In the last video, we started to go through a full analysis for this function f of x equals 6x plus 1 squared minus 3. And now we got to the point where we have our quick sketch, which is really important to draw. Notice here with my quick sketch, I should have included that coordinate there. It's really important with quick sketches that you actually write in the values of the points. And from this quick sketch, I noticed that there are in fact two x-intercepts. One x-intercept, two x-intercepts. And the question then comes, well, how do I solve for these? So we remember that x-intercepts occur when y is equal to 0. So that is like saying, let's just take a second and let's write the function down here. F of x equals 6x plus 1 squared minus 3. So that's like saying that f of x equals 0. Remember, f of x is y. So what we're going to do here, if we want the x-intercepts, we're going to set this equal to 0 equals 6x plus 1 squared minus 3. And now we're going to try and solve for x. Now, students sometimes have trouble with algebra in isolating for a variable. And one strategy I like to recommend is that we are all familiar with bedmass. And what I mean by that is if I picked a value for x and substituted in, you would follow bedmass to get the resulting f of x, or y. I'm actually doing the reverse now because I know what y is and I need to undo everything that I would have done to x to get to y. So you can, to help with algebra, you can actually think of working through bedmass in reverse. So the first thing I'm going to do is look at this and say, is there any subtraction? And in fact, I see subtraction right there. So the first thing I do is I bring the 3 over. More appropriately, I say I add 3 to both sides. I look, is there any addition? And there is addition, but it's inside the brackets, so I can't do anything with it yet. So then I say, is there any multiplication? And there's a 6, so I'm going to divide both sides by 6. So I'm going to have 3 over 6 equals x plus 1 squared. And that reduces to 1/2 equals x plus 1 squared. And let's just come on up here. And this is a very important point. Let's scroll back up to our graph. What we can see here is that there are two solutions, or sorry, not solutions, there are two x-intercepts. And the question might be, well, how do we come up with those algebraically? And that's where we go back and we revisit an idea we talked about earlier this year. And that is the difference, or that idea can be shown by talking about the difference between x squared equals 9 and x equals root 9. And what we discussed earlier this year was that if you have to actually take the square root of both sides, you need to account for both the positive and negative case. So we see here, I'm at exponents, I have to take the square root of both sides. So I'm going to take the square root of 1 over 2. And that is, I have to account for the plus and minus case. And that's equal to x plus 1. So therefore, we can get x is equal to minus 1 plus or minus the square root of 1/2. And that gives me my two possible x values. The first possible x, we can call that x1, is negative 1 plus the square root of 1/2. The other value, x2, is equal to negative 1 minus the square root of 1/2. And those are your two possible values. A nice little thing you can see here graphically is that we see that the x-coordinate for our vertex is negative 1, so I'm adding root of 1/2 to one side of it, and that means that's that point there, and then I'm subtracting root 1/2 to the other side of it. And that, the reason we have this plus minus case is because of this symmetrical argument with this shape. So this is in essence a full analysis of a quadratic relationship. So anytime you get a quadratic relationship, you should be going through in your head and answering these. The more you do, the faster they get. In the next video, we're going to work through another example, but we're going to not only do a quick rough sketch, we're going to do a detailed sketch, which is going to help us really understand how to apply transformations. I hope that helped.